Are we alone? Rethinking the odds of intelligent life in the universe. The universe is vast, so vast, in fact, that it staggers the imagination. Billions of galaxies, each with billions of stars and untold trillions of planets. With numbers like these, it's hard not to wonder, could intelligent life exist out there somewhere? Or even more mind-bogglingly, could it be that we are truly alone in the cosmos? Welcome to Understanding the Universe channel. In this video, we'll take a fresh look at one of humanity's deepest mysteries, the chances of intelligent life in the universe. Along the way, we'll explore scientific theories and philosophical perspectives, weaving together observations from the far reaches of space with discoveries made here on Earth. Let's begin. To understand the enormity of this question, we first need to grasp the sheer scale of the universe. The numbers are almost incomprehensible. Astronomers estimate there are over 100 billion galaxies in the observable universe. Each galaxy contains hundreds of billions of stars, and many of those stars likely host planetary systems similar to our own. If even a small fraction of these planets are within habitable zones, the sweet spot where conditions might support liquid water, the potential for life seems almost inevitable. Yet despite massive efforts from scanning the night sky with powerful telescopes to listening for alien signals through projects like SETI, we haven't found a single shred of definitive evidence for intelligent civilizations. Why? Could it be that life really is exceedingly rare, or is there something fundamentally flawed in the way we're searching? To frame this mystery, many turn to the famous Drake equation, proposed by Frank Drake in 1961. This formula estimates the number of advanced extraterrestrial civilizations in our galaxy capable of communication. The equation takes several factors into account: the rate at which stars are formed, the fraction of stars with planets, the number of planets that could support life, and so on, all the way to the likelihood of intelligent species surviving long enough to send detectable signals. At first glance, it's a hopeful equation, but here's the catch. Most of its variables remain uncertain. For example, while we're finding more planets in habitable zones, we don't actually know how often life emerges, or how often it evolves into something intelligent like us. If even one of these variables is lower than we think, the odds of neighboring intelligent civilizations shrink dramatically. Or maybe, just maybe, we're failing to understand what intelligence or communication even looks like elsewhere in the cosmos. Part of the problem might be that our search so far has been rooted in assumptions that life elsewhere will look or behave in ways familiar to us. This Earth-centric bias could be limiting the scope of our imaginations. Take, for instance, communication. When we think about aliens reaching out, we often envision radio signals or some form of technology akin to ours. What if extraterrestrial intelligence prefers a completely different medium? Perhaps they use methods of communication we can't yet detect, like signals encoded in light frequencies beyond our observational capabilities. Moreover, what if intelligent civilizations don't want to be found? Could advanced species, having seen the chaos of the universe, or even survived interstellar conflicts, intentionally hide their presence? Then there's the question of form. We assume intelligent life must resemble us biologically, carbon-based, needing a specific set of environmental conditions. But what if intelligence thrives in entirely unexpected ways, such as beings made of silicon, plasma energy, or even forms that we'd struggle to recognize as alive at all? Breaking free of these assumptions might be the key to making progress in our search. Guiding us further are lessons from right here on Earth. Over the past few decades, scientists have made incredible discoveries of extremophiles, organisms that thrive in environments once thought utterly lifeless. These creatures have been found in places like acidic hot springs, deep-sea hydrothermal vents, and frozen Antarctic lakes. Some even survive in high doses of radiation or complete darkness. Their existence proves that life is astonishingly adaptable and resilient. If life can emerge and endure under such extreme conditions on Earth, could similar forms exist on planets that seem hostile by human standards? For instance, beneath the icy surface of Jupiter's moon Europa, or in the methane-rich atmosphere of Saturn's moon Titan. These discoveries expand the possibilities, suggesting that life elsewhere might evolve under conditions vastly different from what we consider normal. Adding to the excitement is the boom in exoplanet science. In recent years, missions like the Kepler Space Telescope and the Transiting Exoplanet Survey Satellite, TESS, have identified thousands of exoplanets orbiting stars beyond the Sun. Among these are rocky planets located in what's called the habitable zone, the region around a star where temperatures might allow for liquid water to exist. Scientists have even coined the term Earth-like planets to describe some of these tantalizing worlds. While we've yet to confirm signs of life on any of them, the data suggests that we might one day hit the cosmic jackpot. And with new technologies like the James Webb Space Telescope, humanity may soon be able to analyze the atmospheres of distant planets for biosignatures, chemical markers that signal possible life. For now, though, all we can do is speculate about what environments these worlds hold and dream of what might live there. But what would it really mean to find intelligent life? And how do we even define intelligence? On Earth, intelligence is often associated with problem-solving, tool use, and communication. But intelligence could take completely different forms depending on the evolutionary pressures of a given world. For instance, could an entirely aquatic species develop complex civilizations without fire, or does intelligence always lead to technology? Perhaps intelligence is more about adaptation than invention. Dolphins, for example, display remarkable collaborative behaviors and communication without needing advanced tools. Could alien civilizations operate similarly, intelligent but not technological, in ways we recognize? Then there's the question of motivation. Even if advanced civilizations exist, would they care about reaching out to others? Or would their priorities center inward, focusing on their planet or species without feeling the need to explore beyond? Even if intelligent life is out there, we face one of the biggest hurdles of all: communication. For decades, we've been trying to detect alien civilizations through methods like radio telescopes, searching for signals across wavelengths. But what if our methods are completely wrong? Some experts suggest that alien civilizations might use quantum communication systems or other advanced techniques that are far beyond our current understanding. Or, alternatively, they might communicate so subtly, for instance through alterations in star patterns, that we fail to notice. It's also possible we've already come across signals but didn't recognize them for what they were. If aliens think and express themselves in ways fundamentally different from humans, would we even know how to interpret their attempts to communicate? Theoretical frameworks also raise the possibility of civilizations so advanced that they operate on a scale beyond human comprehension. The Kardashev scale, for example, categorizes civilizations by their ability to harness energy from their home planet, their star, or even their entire galaxy. A Type I civilization masters planetary energy, while a Type II civilization might harness the energy of its star through something like a Dyson sphere. A Type III civilization, they could control energy on a galactic level, potentially rendering their technology indistinguishable from natural phenomena. If neighbors like these exist, they might not care to interact with Type 0 civilizations like humanity, which hasn't even fully mastered its own planetary resources. Or their methods of interaction might seem magical or incomprehensible to us. Then there's the hypothesis that some civilizations might leave the physical universe entirely, existing in digital or non-material forms inaccessible to human detection. This idea opens the door to realms of possibility far outside traditional science fiction. All of this leads us back to one of the greatest enigmas in astronomy, the Fermi paradox. If the numbers suggest intelligent life should exist, then where is everybody? There are countless theories attempting to explain the paradox. Some propose that intelligent life is exceedingly rare because the jump from simple to complex living organisms is extraordinarily difficult. Others suggest that civilizations inevitably self-destruct before they can achieve interstellar communication. Another idea is that intelligent civilizations might become entirely uninterested in outward exploration, a concept aligned with some great filter theories, which hypothesize that a particular hurdle prevents most species from progressing to a cosmic scale. Regardless of the outcome, the search for intelligent life raises deeply philosophical questions about our place in the universe. Are we truly unique? If we are alone, does that make life more precious, or does it render existence an anomaly? On the other hand, if intelligent life is common, what would it mean for humanity to finally connect with another sentient species? It could redefine everything, from how we view morality and our planet's resources to our understanding of time and consciousness itself. Many wonder, is life in the universe driven by chance, fate, or deeper purpose? The prospect of intelligent aliens might not answer those questions, but it certainly broadens the ways we think about them. As we continue our search, emerging technologies offer thrilling possibilities. The James Webb Space Telescope is already unlocking new insights about distant exoplanets. AI systems are refining our ability to analyze massive quantities of data, potentially revealing patterns we might otherwise miss. Upcoming missions to moons like Europa and Titan could yield direct evidence of microbial life within our very own solar system, a stepping stone to searching farther afield. International collaborations and private space companies are also accelerating humanity's ability to explore the unknown. Who knows? The next major breakthrough might already be in progress. Standing under the night sky, it's impossible not to feel a mix of awe and curiosity. Are we rare beyond imagination, or just one of countless civilizations scattered across the stars? While the answers remain elusive, one thing is certain: the search for intelligent life pushes us to dream bigger and explore further. Whether we find them tomorrow, in 1,000 years, or never at all, the journey itself may redefine how we see the universe and ourselves. What do you think? Will we ever make contact? Share your thoughts and theories in the comments below, and let's keep the conversation about humanity's place in the cosmos alive. The answers might be out there, waiting.